Hey everyone, thanks for coming. My name is Atul Gupte, and I'm the product manager for Data Science Workbench. And today I'm super excited to talk to you about how we're going from raw data to informed intelligence with Uber's Data Science Workbench. A little bit about me. I was an engineer before this and turned to product manager. I was at Zynga helping build games like Farmville, as well as later their mobile advertising platform. At Uber today, I am a product manager on the product platform team responsible for a few different areas, notably Data Science Workbench, which you'll be hearing about today, our interactive analytics platform, as well as our data knowledge platform. So if you have questions about any of those, come find me after. To get started, I think it's important to understand what our mission is in this world. Our mission is to ignite opportunity by setting the world in motion. Obviously, we're a global company existing in hundreds of cities across the world, moving millions of riders in millions of trips every single day. All of this is possible because of a lot of data. Data informs every single decision that we take at the company. This data includes all sorts of things that we collect during the trip, our interactions with support, weather data, trip data, traffic data that we collect from cities. All of this is used by multiple teams across the company to take several product decisions and several operational decisions, things like how much we need to pay in promotions, where our vehicles need to be positioned, how many riders do we expect to take a trip in the next week, things like that. So that is the secret sauce that really helps Uber move. Now, obviously, this is a lot of data, and this data needs to be organized. So I think it's important to see what our data platform looks like, because I think this will become relevant as we progress through the rest of my slides. So several different layers here. The bottommost layer is where data comes in. So this includes data that comes from various apps, the data that we purchase about weather or traffic, and other external data sources. All of this lands in our storage infrastructure as raw data. So this is in our multiple data centers and multiple storage technologies. Of course, this data is pretty useless the way it is, right? Until it's actually transformed into tables or custom data sets. So we have teams that build ETL frameworks and data integrity processes that make sure that this data flows into the right place and is accurate and usable, right? Once we have that, that's where things get interesting, right? So the top two layers are where all the magic happens. We have business intelligence teams that build data exploration platforms. They maintain our query engines and also create knowledge bases that store and organize some of this information. We have a pretty robust experimentation platform that does A/B testing, which is, as you may imagine, tests between two different variants to see what works and what doesn't. And then finally, we have the little green square. That's what I'm going to be talking about a little more. But we have data science tools and machine learning platforms that help teams make much more sense of all of this data. And then finally, at the very top, we have the data where users can consume these business insights, from dashboards or alerting platforms or monitoring platforms, right? And that's fairly self-explanatory. So that's kind of how our data platform looks. But before we start building tools or services that help teams understand and make sense of all of this data, I think it's kind of important to understand who we're building for. So what we have here is sort of a brief overview of the personas that we're serving, that our data platform is serving. On one end of the scale, we have Reliant Rebecca. So she and her peers, their job involves taking decisions based on business insights. Often they don't have the skills or don't have the time to actually mine these business insights and create these visualizations themselves. This includes marketing managers, product managers like myself, etc. They rely on someone else to kind of help them make these decisions. We have monitoring Matt, the other persona. He's fairly familiar with a small subset of metrics, and his job involves monitoring these metrics, taking action based on what he sees. He's fairly familiar with SQL and dashboarding solutions, and this involves, or this persona serves a lot of our regional operations talent. Both Reliant Rebecca as well as monitoring Matt actually rely on the work that analyst Anna does. She's responsible for actually building out the dashboards, customizing the queries, running experiment analysis, and feeding this information back into interfaces that Matt and Rebecca are familiar with. In this role, we have operations managers, product analysts, data analysts, etc., who can actually take all of the data that we have and build things that can feed into the requirements for Rebecca and Matt. And then finally, at the top end of the technical spectrum, we have inventor Ivan. This persona includes our data scientists, software engineers, machine learning researchers, AI researchers, et cetera. And as you can imagine, they're actually doing a lot of the heavy lifting. They're building the data pipelines, they're building the experimentation platforms, they're building the machine learning models, training these models, and they bring to the table advanced Python knowledge, advanced programming knowledge. So this is kind of the spectrum, and I believe that these personas are fairly well represented at any other data-driven company that there might be out there. So this being said, this is the personas of people that we're serving. In early 2016, though, a lot of the pain points that we were seeing were around the inventor Ivan persona. So Uber is growing pretty rapidly, and we are hiring data scientists and engineers in vast numbers, right? But these people are finding it very difficult to do their work. Primarily data scientists, right? As they came into the company, they found that getting started was incredibly difficult. They had to kind of build their own hardware. They were running a lot of this stuff on their own laptops. They were cobbling together infrastructure in different ways. So each team was doing kind of what they had to get things working. It wasn't just hard to get started. They also had to access all of the various services and platforms that I described previously, right? So they had to build their own custom connectors to interact with all of these services, to interact with all of these different query engines. So that was, again, a complicated process. And that meant that collaboration was not just difficult, it was almost impossible, right? Every team was doing their own thing. They were speaking their own language. They were writing their own connectors. So if something changed, they had to kind of make changes across their entire workflow. This meant that data scientists spending a lot more of their time handling these kinds of things. This is not their job. They should be doing data science, right? But they were worrying about getting their infrastructure together and making sure that libraries are updated and things like that. So this meant that they only had time to look at maybe the top 10 most impactful things. But as Uber expanded globally, we saw that there were a lot more interesting problems that needed to be solved that could be solved with data science inputs, but they simply didn't have the time to look at some of these things. So we realized that we needed a unique solution. And the approach that we took was two-pronged. We wanted to improve the productivity of inventor Ivan. We wanted to get the data scientists and engineers more productive and enable them to do their work more efficiently and quickly, right? But at the same time, we wanted to improve, we wanted to level the playing field and improve the level of access that there was for the monitoring Mats and analyst Annas. Because our belief was that if we gave them access to some of these advanced tools and some of the more advanced techniques, they could actually do their jobs much better and much more efficiently. To do this, we realized that the best way to do this at the time was to actually build out our own solution, which meant that we could integrate it really well with the existing tools that we had, the existing platforms that we were building at the company, and also customize it for the needs that we needed. Like a lot of the things that we do are geospatial analyses, for example, or machine learning for various business units, right? So we realized that building something of our own would really sort of help the use case here. So we had varied users. I described them to you previously, the varied personas that we wanted to serve. They all had different infrastructure needs, right? So some of them just required a CPU that was just a little more powerful than their MacBook Pro. Others required advanced GPUs, multiple GPUs, for example. We also wanted to give them single window access. So like I mentioned, we have a lot of different tools and platforms within Uber. It's hard to kind of build these connectors yourself. So we wanted to give them a single window that allows them to quickly and easily access all of these different interfaces. And then finally, we're a pretty large global company. We operate in multiple geographies that have various compliance requirements. And as we grow, we have a lot more people using these tools and services. So we wanted to make sure that whatever solution we had, met certain cost and compliance requirements. So with that said, we decided to build something that we call Data Science Workbench. And we started with a pretty simple mission, right? Our mission was to democratize data science by giving all of these users access to reliable infrastructure and advanced tooling in a community-driven learning environment. So some of this is self-explanatory, right? Reliable infrastructure, you don't want your machines to crash. You want advanced tooling, right? So give them access to the best-in-class tools and services so they don't have to kind of reinvent the wheel for themselves. And finally, I'll talk a little more about this a little later, but the community-driven learning environment was a very important aspect of when we thought about building this product, right? So when we started out, we decided that we wanted to focus on 3 key features, right? So the first one was interactive workspaces. We centralized on using Jupyter and RStudio as the 2 IDEs that teams are already using in some way or form to do data exploration, data preparation, or ad hoc analysis. The next thing that we wanted to do was give them access to advanced dashboarding. So this allows them to visualize some of the rich insights that they've derived from their analyses and share these with, people who have fewer technical skills. So for example, with the analyst Anna's, Reliant Rebecca's, or monitoring Matt. And finally, we wanted to empower them to do business process automation. So Uber, as you can imagine, is a complex global business, a lot of processes that are inherently manual in nature. But if we could automate some of these things, or even automate things like model training or pulling data, we could actually empower these people to do a lot more with their time and with their skills. So these are the three things that we decided were important as we built this product out. And here's a quick schematic of kind of what we do. Data Science Workbench is primarily a browser-based tool that gives you access to Jupyter or RStudio in any browser window. It's backed by a management service that does the things that you imagine a management service does: file management, package management, enforcement of storage quotas, enables some collaboration, hosting dashboards, things like that, things that you don't want your end users to worry about. Each user gets a fully customizable session. It's a Docker container isolated from every other user. So users here can install any packages they want, update or downgrade versions. They can basically do whatever they want to. And if they do something bad, it doesn't really affect other users of the platform. All of this is backed by a persistent storage system. So if something happens and your machine dies, you don't lose your work, you don't lose your files. And finally, the single window access that I was talking about. This container has access to pretty much everything that an engineer can do at Uber. So you can write interactive queries with Presto, run real-time queries on Pinot, do some machine learning using Spark. If you want deep learning, we support TensorFlow and GPUs. You can do batch analytics with Hive. Pretty much any service that exists at Uber can connect with this. This means that data scientists and engineers and analysts who are using our product don't need to worry about how they can connect to something else. It's already done for them. They can just go ahead and start using it, right? So a quick look at what this looks like. This is what our UI looks like. We have containers, RStudio or Jupyter-based that the user can use. As you can imagine, the Jupyter interface looks exactly like what Jupyter looks like on your laptop. So there's nothing new that a user needs to learn. It's exactly like how they're used to it, right? Or if you use RStudio, again, it looks like the RStudio interface that you could install on your own computer. The next thing that we have is dashboarding, right? So this is a way that you can visualize some of the rich insights that you've derived. These dashboards can be shared across the company, and they allow the less technical users to, get the same benefits from the analysis that the more technical users have done. And then finally, we have something that we call the knowledge base that allows you to share these insights more broadly. So if you've discovered a technique that really helps you, you've discovered a technique that's useful, you've done some analysis that's really powerful, you can actually share this with the rest of the company so that people don't reinvent the wheel. They can quickly look at what you're doing and get started with that itself. So they can clone your analysis and then make the required changes, right? And so this kind of goes to the community building aspect that I was touching upon earlier. So that sounds great, but I wanted to talk to you a little more about the use cases that we've kind of seen teams at Uber use our product for. And that's actually going to drive some of the things that we're doing in 2019 that I'll also talk to you about. So the most common use case, obviously, is exploratory machine learning and model training. The inventor Ivans of the world, the engineers and the data scientists, they're building complex models to serve various use cases at Uber. Some of these include restaurant recommendations in Uber Eats. So if you open the app and you see the restaurants that are suggested to you, some of that work was done using Data Science Workbench. We have a pretty vast support organization that is trying to resolve support tickets as fast and as efficiently as they can. So we're building NLP models using Data Science Workbench. On the safety front, we're building models to do trip classification. On the risk front, we're doing driver account checks to make sure that rides are safe. Operations teams are building LTV models to make sure that they're allocating incentive spend effectively, right? So all of this is things that engineers and data scientists can do much more efficiently with powerful infrastructure that we're offering them. The next use case that we spoke about was dashboarding. And so this is something that has been pretty transformational for teams at Uber. The dashboard that you can see here is actually something that we call the Driver Insights tool. It's being used across Europe, Middle East, and Africa, where when drivers go to green light hubs run by Uber, they can actually get a much better sense of how they're doing on the platform and how they can maximize their use of the platform to make more money, to get better ratings, and to kind of get more out of the Uber platform itself. Now, all of this data, as you can imagine, already lives in our data stores. It already is in our tables. It's already there in our pipelines. But being able to surface this to the less technical users who are sitting in Greenlight hubs has been truly transformational for the way that business is run. And then finally, it's business process automation is sort of a major use case that that we've discovered teams have. The example we have is from Mexico City, where teams discovered that car theft is a major problem. A lot of these vehicles can, of course, end up on the Uber platform. We don't want them to, but unfortunately, they can. With hundreds of thousands of vehicles operational on the platform every day, and hundreds more joining every day, this becomes a really hard problem to solve, right? Sure, you could have a few humans sitting there and manually verifying every single vehicle, but that quickly becomes a problem of scale, and it's also a really repetitive, boring task that you really don't want someone to do. So what these teams are doing is they're using Data Science Workbench to automate this process. They're checking with the Repuve public vehicle database in Mexico, and it takes under half a second to perform a single check. And they're performing hundreds of thousands of these checks every single day to make sure that no stolen vehicles end up on the platform. If they do detect a vehicle like that, the driver is deactivated, they go through the process, they're invited to a Greenlight hub, verifications are done, and all of this is automated. And there are many, many more examples like this where teams are, taking an inherently manual, error-prone, time-consuming process and, using the power of Data Science Workbench to make this better. So through this process, over 2 years of building this product, we've actually learned a few interesting things, and I feel like it's pretty relevant for anyone who's trying to embark on this journey of either using a similar product, launching a similar product, or building something like this in-house, right? So the first one is build for the experts, but also design for the less technical people. When we started out, we really built this for the inventor Ivans, for the data scientists, for the engineers. But we took care to actually design our solution for less technical people so they could onboard onto this fairly easily and effectively. The next thing is don't stop at building what's known, but empower people to look for the unknown. With Data Science Workbench, we're doing this in two different ways. One is with the knowledge base, where we're showing people, what are the different things that people are doing on the platform so they can get inspired to do some of those things, replicate those things, or extend those things. We're also, giving them access to building out rich web apps and dashboards. So that way they can actually build out these interactive products which don't exist today, but there's no good reason why they don't. And then finally, create communities of both data scientists and non-data scientists. By bringing all of these different personas together, we've actually seen a wealth of different use cases, right? It's not just building complicated data science models, machine learning models, but it's also doing like some basic automation, right? And this would have never happened if we had restricted the platform just to data scientists, because they would have never seen that, visceral real-world use case that's needed to be solved. So with that said, this has really informed what we've done, not just over the past 2 years, but also what we're doing in the course of 2019 and beyond. So I've kind of split this up into 3 different things. One is we want to strengthen our foundations. For us, dependency management is a big problem. What does this mean? So we give users their own Docker container that actually has any packages, any versions that they want to install. It becomes hard for us to manage these dependencies, especially when containers die, machines go down, and we want people to recover from these failures. So perfecting dependency management is a major task that we're embarking on. We want to enhance these customized environments by giving people more control over when these updates happen, how these updates happen. And finally, we want to improve integrations with cloud providers and give people access to more advanced GPUs. We're seeing that deep learning is becoming an emergent use case for multiple teams at Uber. And we want to give them access to GPUs so they can do this better on our platform instead of having to go to a separate platform to do this. We're also focused on making everyday things extraordinary. Collaboration for us has been a big pain point. As teams have grown, teams have expanded, and their scope of work has also expanded. We're seeing that more and more teams want to work together. They want to share their work with other members. They want to onboard more teams, onboard more members, and we want to make this easier. So we're thinking of doing stuff like collaborative projects where you have a project where you can share a bunch of different files, schedule jobs, dashboards, all of the various artifacts that go into our product. So multiple people can read these things, edit these things, and make changes if required. We're also focusing on version control using Git and code reviews so that we can enforce engineering best practices on our platform as well. We're seeing that teams are building pretty impactful and honestly scary solutions, right? They're building these things that really impact our end users. We want to make sure that they bring in the same rigor, on the engineering front that we do when we build our apps and other systems. We want to make knowledge sharing more effortless. So knowledge base was a great start for us, and we want to continue building that out so that people can share their insights and their techniques with more people. With security being a challenge, we want to make granular access control and build in more advanced security features so people can share only as broadly as they need to. They can only give the kinds of access that they should. And we want to build more advanced support for web apps. So the dashboard example that you saw, we want to build more such things so that people can use Data Science Workbench to prototype these things, build out these solutions, and then share these with the less technical users. And finally, we want to innovate and differentiate, right? Machine learning has been a major focus area for the company, and productionizing machine learning models is something that we're actively building out. So we already have integration with PyML, which is a Michelangelo initiative that allows you to go from a notebook to a served model with just one single click. So we want to continue investing in things like that. We want to invest in plugging in feature stores, model stores, and inference services so that you can plug in whichever one you actually want to use. We're investing in remote kernels for SparkMagic or TensorFlow and Horovod. We want to be able to trigger Python microservices from a scheduled workflow. And our vision for the product remains, we want to be resilient, reproducible, Dockerized, and scheduled. So we want to allow people to do amazing things with the platform without actually having to worry about the infrastructure, the scheduling, the reproducibility, or the support. We're also considering open source. That's been something we've heard from a lot, and that is a path that we're going down. We're investigating what we can do to go down that path, what changes we need to make, and how we need to evolve our product to actually support open source requirements. So that's all I have. Thank you so much for listening. We have a blog post on eng.uber.com/dsw to get more information.